We're going to look at what's called conjunctions and disjunctions in lesson 89. But before I start lesson 89 and these concepts, there's a third concept in lesson 89, and it's finding chords and secants. It's determining the length. And you can just find that for concept 89C. Just go to lesson 101 on my geometry page. Okay, that's lesson 101 on my geometry page. So I'm not filming the same thing twice. So that's how you do 89C. Now let's look at conjunctions and disjunctions. Really quick, English, that means and or. But all we're going to do is graph what it's telling us to graph. So let's look at our two equations. It says graph negative x minus 3 is less than or equal to 2. Well, the first thing we got to do is solve for x. So I'm going to add 3. So it's negative x is less than or equal to 5. Divide by negative 1. So what happens is I have to switch the sign for when I divide or multiply by a negative. So I switch that sign. So I got x is less than or greater than or equal to negative 5. Now let's look at this one. All right, I'm going to add 2. This one's easy. X is less than 3. So I got x is greater than or equal to negative 5. Oh, I'm sorry. I wrote this problem down wrong. So this is actually when I would add 3. This is my bad. Real quick. I would add 3 to a negative 2. So that would be positive 1. So it would be negative x less than or equal to positive 1. Divide by negative 1. Get x, flip the sign, greater than or equal to negative 1. My bad. So x is greater than or equal to negative 1, conjunction, and x is less than or is less than 3. So I'm going to start by creating my number line here. And my domain is integers. So that means I'm going to be filling in circles for numbers that can apply. It's not going to be everything in between each number because it's integers. So greater than or equal to negative 1. So there's negative 1. It can be equal. It can be greater than negative 1. So we can circle these in all the way until 3 because x has to be less than 3. So the only integer less than 3 would be 2. So those would be our 4 integers that would be able to plug in for x. So negative 1, 0, 1, and 2 could plug in for either of those graphs. Okay? Or it could plug in for both of them. Sorry. So that's one conjunction. Now let's look at another one. The only difference here is it makes this kind of look funky. It gives negative 2 is less than x minus 2 is less than or equal to 4. We're going to separate this into two equations. So we're going to call it negative 2 is less than x minus 2. And then we stop there. We stop at the next sign. So then we have x minus 2, kind of starting from this sign, less than or equal to 4. So these are my two conjunctions that I got to solve for. So I'm going to add 2. So x is greater than 0. I personally like x on the left side, so I'm going to flip this. These are the same thing. I just flipped the sign when I switched the sides. Okay, so x is greater than 0. Add the 2. All right, and x is less than or equal to 6 when I add the 2. So here's my two numbers. My domain is real numbers. So I'm going to graph 4, 3, 2, 1. All right, x is greater than 0. So since it's real numbers, I can do an open circle, or that's not 0. I can do an open circle on 0, closed circle on 6, and if it was integers, I would have to fill in dots. But real numbers is everything in between those. So that is how I would graph x is greater than 0 and x is less than or equal to 6. Now let's look at one more. Okay, Now we're going to look at disjunctions. Disjunctions. Once again, it's really, you're just graphing what it tells you to graph. And disjunction means or. So let's look at one example here. It says we'll do example 3. It says graph negative x is greater than or equal to 3, or negative x is less than 1. Stupid. Negative x less than negative 1. My domain is real numbers. We are going to keep it real. All right, keeping it real. So I start by solving for x. So I divide by negative 1. I get x, flip the sign. X is greater than or equal to negative 3. Divide by negative 1 here. So flip the sign. Or x is less than, or sorry, x is greater than positive 1. Make my number line. I like to put at least 1 on the opposite end of my two numbers that I have. It's real numbers, so I can do an open circle and a closed circle here. Now it says greater than negative 3. Okay, x is greater than negative 3. Oh, I never actually flipped my sign. My bad. Y'all were probably telling me to, and I never did. Okay. I divide by negative, it'd be less than or equal to negative 3. My bad. Okay. So less than would actually be shading this way. Greater than would be shading this way. So my domain would consist of any numbers negative 3 under that, or any numbers after positive 1, but nothing in between negative 3 and 1. And that's how I graph a disjunction. You're really just telling you, or you're really just following along what it's telling you to graph. And that is the end of lesson 89.